Hi, and welcome to CSCI 1300. In this video, we will cover the main activity of programming and how to design algorithms to help solve a given problem or task. Programming, at its most basic level, is a process of identifying a problem and its solution, then finding what is needed to perform a task in order to produce a desired solution to the problem. You can break this into a series of steps. The first step would be to identify the problem. You would need to first identify the problem. Once you've identified the problem, you can identify a desired solution. You would then identify a series of steps to solve the problem and get a solution. You would also need to identify anything needed to start working on the problem. Then you would have to perform a series of steps after identifying what you would need to start, or operations, to reach a solution. And then lastly, you would also need to perform an analysis where you should check your solution you get from performing these steps against the desired solution you identified when you first started. Algorithms at their core, and most programming at its core, can be broken up into 3 steps. You're going to have some input of some type. For instance, you might need certain tools, or you might need to have certain resources in order to start. Those would be the inputs to your problem. You'll have some form of an operation sequence or a series of steps where you'll take in those inputs, those things that you know you need to start working, and you'll start working on the task and performing a series of very clearly defined steps or activities in order to reach some output or some desired solution. In order for a computer program to provide an answer to a problem that computes an answer, it must follow a sequence of steps that is unambiguous, meaning that it is clear to anyone who reads it. It needs to be executable, meaning that every step needs to have some form of task. It has to solve something. And it has to be terminating, in the sense that those executable steps will not continue on forever. There will be some point when there will no longer be any work required and the job will be done. And that will be when your program would terminate. For instance, let's come up with an algorithm for baking a cake. Well, to bake a cake, we'd probably have to identify inputs. So let's start with an input section. Well, one thing we would definitely need is we need to identify and gather ingredients needed for the cake. Well, we probably also need to identify and gather any necessary equipment, like utensils. So maybe we need like spatula, maybe we need, a mixer. And that's part of the input sequence. Then once we have our inputs, we can start on our operation sequence. In the operation sequence, we should start doing something with the inputs that we have defined. So maybe we should mix the ingredients Maybe we should preheat an oven before doing anything else. And we might need to go ahead and just let bake the cake in the oven for a set period of time. And lastly, we would have to maybe let the cake cool. And after that, we would have some output, which would be that we could enjoy the cake. Now you can see that we basically broke up the operations of going through the necessary movements or steps of baking a cake into 3 categories. What did we need to start performing the task? What do we actually have to do to actually perform the task itself? And what are we expecting to have as a result of that job, that task? What are we actually getting as our output from this particular task? These are the basics of understanding algorithm design. Thanks for watching, and happy coding.